Hello guys. Have you solved the given problem yesterday? Meanwhile,
Oh, yes, sir, but having some doubt, can you please solve that, sir?
yeah, tell me where you're having the doubt.
Sir, in that you told that we should not consider that overhanging part. In that case, there will be an moment, and there is also a UDL and a point load. No, sir.
Yeah.
How to calculate point load, sir? With point load,
You don't get any fixed moments, right? Because of that. For moments, no, it won't. You don't have any fixed moments. So because of the point load, you don't have any effect actually.
okay.
Imagine if that point load is not at that joint. If it is in the
So
span,
we have to consider only the UDL for that.
yeah.
We'll try with that, sir. Second problem, we got the answer, sir.
Yeah, second part it's fine. There is nothing there.
Sir, and one more doubt, sir.
Yeah, please.
Went through some questions in IES, sir.
Yeah.
In that, they are asking us to draw. They are asking only the bending moment diagram, sir. They have given 4 options with some loading cases, sir. Is it only method to follow that either moment distribution method or slope deflection method, or is there any shortcut to draw BMD alone, sir?
Can you forward me the question first of all? I'll just look at it and tell you.
Okay, sir. Okay, sir. Because in some questions they are asking just the diagram alone, sir. For that question, is it necessary to solve the full problem and to draw the diagram, or is there any?
There are no such kind of things. If you can send me, I'll just give you a hint.
Okay, sir. Okay, sir.
Okay, just meanwhile, if somebody comes, I need a quick answer about this. I don't know which method you will use, but all I need is quickly, can you please find out what is my slope at point B? Quickly, can you guys find out what is the slope at joint B? Meanwhile, others can join. Sorry, I haven't shared a screen, right? Sorry. Just writing on that. Just a second. Do one thing, guys. It's been updating. Just a second. Yeah. Can you please find out quickly what is the slope at point B? We don't need much time to solve this problem, it seems. Can you know how you are solving this problem?
Slope deflection method, sir.
Okay, fine. You can use that. Come on, guys. What's the answer? What happened? Can I know? What's the issue? It should not take much time now. If you can speak out, then we can discuss.
Sir, minus 0.5.
Minus
0.5
0.5
divided by E.
divided by A.
Yes, sir.
Is it? What about Ramya?
Sir, found out the slope deflection equation, sir.
Sorry? Please come again.
So found out the slope deflection equation, sir.
Yeah. What is the answer? Did you?
1 minute, sir.
I don't think it will take much time. Only the unknown variation of deflection is TRB, right? Now for that, what is the equation that you have to use? Summation of moments at B equal to 0. How many moments are there? Moment at B towards A plus moment at B towards C should be 0. What about moment at B towards A? What is the unit? Moment at B towards A, what is the fixed moment? WL square by 12 clockwise. So plus W is 12. 12 into 4 square, 16 by 12 plus 2EI by L. 2 times of near end rotation. What is the near end rotation? B. What is the foreign theta A? It is a fixed support. So 0. There is no sinking of supports, nothing. Similarly at BC, there will be anti-clockwise, so minus 12 into WL square, मतलब 16 by 12 plus 2EI by length is 4, 2 times 1 year and rotation theta B. What about theta C? Again, it is a fixed support, 0. There is no sinking of support, that will be equal to 0. This gets cancelled and this gets cancelled. And if you are solving this, how much you are getting understood? Vishnu, can you tell me how many got 0.5? It is a clear-cut problem, it seems. Can I just know where you guys face this problem? Why you guys could not able to solve it?
Somewhere in the middle.
Sir, sir,
Sorry?
how come theta is 0 there?
How come?
2.
How come it is 0?
So 2E theta B.
This gets cancelled. How much will it? What is it minus 2? Yes, theta is equal to 2. That's
Sir,
what
0, 0.
that will be 0. Right. How come you got the value? Where you have counted the method? I'm just curious that where you have done the method. That's it. Why you got 0.5 where?
Minus 0.5, sir.
Yeah, how you got minus 0.5? I'm just curious about that magnitude. That's it. How come? If this and this both are gets cancelled, I didn't see any variable that goes to the right side. What about Ramya? What about you?
Sir, how come minus, sir, there?
Where? Here.
That second, yeah.
What are the fixed end moments at B towards C? What is the value?
6.
WL square root 12, and what is the direction?
Yeah, sir. Yeah, sir. Okay, sir. Okay, sir.
Why, like, where you have done them? Like, I'm just curious, why you are not able to get up to the solution? I just want to think about that. Is it application of the method? Where? If you can tell me, then
We couldn't be fast, sir. That is the problem.
you could not.
Now, when we are going with the method, we are concentrating only in that. The past methods, we are not able to recollect, sir. That is the
No,
main problem.
hardly we have not been a week, right? Hardly. I think so. It's not even a week, isn't it? Okay. Now, can you do one thing? Can you apply the moment distribution method? Can you? What about the final moment that you are getting there?
Where, sir?
Apply the moment distribution method in this method and find the quickly final and moments. I don't think it will again take a much time. Take just 5 minutes and do it.
So
What about
using slope reflection or moment distribution?
which now? What about the distribution factors? By looking at them directly, you can tell. What about the distribution factors at joint B?
4EI.
Yeah, 4A on both sides, isn't it?
Yes, sir.
EA and lengths are also same. That means what about the distribution factors? 0.5 and 0.5.
0.5.
Yeah. Quickly just try to draw the diagram and let me know what values you will get. Come on. What are the fixed end moments?
Sir, in this case, we have to start from the middle of the support, right, sir?
What does it mean by middle of the support?
That is from the B point.
From the B point?
We have to balance from, we have to start from the B point,
Yeah.
right?
Yeah, right. Now, I don't think you can take much time.
Sir, it is minus 16 plus 16.
Minus 16 plus 16, right? What
Yes,
about the
sir.
fixed end? Now tell me, I don't think you need any iterations, isn't it?
Yes, sir. Directly we got the
They
answer.
are automatically balanced. Here you can say that here it is minus 16 plus 16.
Minus 16 plus 16.
Equal, isn't it?
Yes, sir.
Equal and opposite sign. Equal to 0. So these are nothing but your fixed end moments, right?
Yes, sir.
Yes, those are nothing but fixed end moments. So this is how you can imagine that they got itself balanced there. Or else you can do work out at another problem. Instead of them, imagine that just for the calculation part, I'm not asking you to do it here, but you can try later on whenever you're having free time. Now, if you can find out again the slopes, I can guarantee that theta A might exist, theta C might exist, but I can say that you will get theta B is equal to 0. This is what we can call it as an advantage of symmetry. You can look at in this problem also. With respect to support B, the given structure is symmetrical or not? Symmetrical, right? So wherever it is symmetrical, we can say that along that section, we can say that the slope of the section will be equal to 0. As it is symmetrical with respect to B, in this case, the slope at point B is equal to 0. Even in this case, it is symmetrical to with respect to B. So that's why you can say the slope at point B is equal to 0. Now, imagine if you want to solve it by using the moment distribution method. Okay. Now, first what you are doing, you can imagine that you understood this logic that as this structure is symmetrical with respect to this section. So what you will do is that if the slope is equal to 0, 0, I can arbitrarily imagine that it is a fixed support. Can I imagine? If I'm saying that my slope at point B equal to 0, can I imagine it like some sort of fixed support?
Yes, sir.
We can, right?
Yes, sir.
So imagine it is 12 kilonewton per meter and it is 4 meter. So if you want to do by using moment distribution method, what you will do? You will find the fixed end moments. What about the fixed end moment? Here it is anti-clockwise. How much the magnitude? Already we have solved 16. Here it will be clockwise 16. But what about at this joint? A. Will there any moment develop there? Will
No,
moment
sir.
develop at joint A? No, right? We
No.
have to balance it. How you will balance it?
By clockwise 16.
Right. So if I'm applying the clockwise 16, here also the clockwise. As far and is fixed, right? How much moment will carry over?
Half of it.
Half of it, that means 16 by 2.
Point
So finally, what about the values? At the support here it is 0, and at this support how much? 16 plus 16 by 2. How much it will be? 24. Even if you take this original problem and if you solve it by using moment distribution method, still you will get the answer as 24 only. So which one will become easy? This one is easier, this one is easy, solving this entire case.
And the method will be easy, sir.
So wherever there is a
So that is a propped cantilever, right, sir?
it will behave like sort of proper cantilever.
Okay, sir.
Only we can say that in reality, by looking at the original structure, we can say that that is a continuous support. But due to the continuity, what we can say is that the slope is also is equal to 0 at point P. The reflection can be like this. So here I have taken slope is equal to 0. And what about the reflection?
If there is a point load in between B and C, we cannot consider this case, no, sir?
Then slope will occur. In this case, the reflected shape will be like this. Here the slope is 0 horizontal line, here the slope is 0 horizontal line, here the slope is equal to 0 horizontal line. Got it? Similarly, what is the difference? Here also, can I apply the advantage of symmetry or not?
Yes, sir.
Isn't it?
Yes, sir.
For the dimension balance of 4 meter and 4 meter. If you apply the symmetry, then but what is the difference between previous case and the present case? In the previous case, the symmetry is exactly cutting at one of the support. But here it is not exactly cutting at the one of the support. It is cutting exactly at the middle. Obviously, if any structure is symmetric, either it will fall along one of the support or it will cut the section exactly at the middle, isn't it? Now, in this case, how can I solve it by using moment distribution method? What do you think where we should apply the current there? In the previous case, what we have done, we have imagined it as a fixed support and then we have solved the problem. We have done nothing, we have done no changes. But what about this problem? Thinking generally and tell me corrections will be applied or not. If we have to apply, on what basis we should apply? As we have discussed in the previous case, as at the symmetry of the section, I am imagining this as a fixed support. This is A, B. As it is not exactly at the same, I am just imagining it as a C dash. Where, while in the previous section, see here, as the section is cutting at symmetry of the section is falling on any one of the support, the entire span of the beam we are considering. But here, are we considering the entire span of BC? After considering the advantage of symmetry, if you can do here, are we considering the entire span of BC or are we considering the half of it?
Answer.
Half of it, right? So that's why what will happen as we are considering only half of the span for the calculation, we have to apply some correction for the stiffness. That is, the stiffness will be equal to, we have to consider half of the original stiffness A, B, C. Okay, this is what the correction that we have to remember. Now, imagine we are solving it by using moment distribution method. How many joints we have to consider? B. There are two members. How many? BC dash and then BA. What is the stiffness for BA? We are considering in BA there is no reduction in the member. We are considering for end is fixed, so we can consider 4EA by L. What is the length? 4. E 4 gets cancelled. That from directly writing it as E type. And what about the BC dash? We have to consider
BC is also
half of
4EI by L. Half of
we are talking about BC 4EA by L. Length is 4 meter. 4 gets cancelled A. As we are considering only half of it, remember only we have to consider half the stiffness. Now, what about the distribution factors then? What about the distribution factors? BC dash is half of EA, BA is EA. What about the distribution factors then?
0.33, sir.
How we have done it?
0.5 divided by 1.5.
1.5, right? I think I have to ask you to what is a shortcut, right? Imagine, let's as of now here it will be 1 by 3 and here it will be 2 by 3. Is it right? Is this right, these two values? Is this value right 1 by 3 and 2 by 3?
Yes, sir.
Okay. Now, what about the moment distribution table that we should discuss? So we have to consider AB, BA, BC dash, right? At this point, what is BA? 1/3. Sorry. Towards BA, it will be 2/3. 2/3 BC dash will be 1. What are the fixed moments here? For AB, 0. For BA, 0. For BC days, how much? You have to consider the original moments only towards that joint. How much it will be? Already we have found out. What are the fixed moments towards C at B? The fixed moments?
Sir.
Minus 16, right? Now,
Yes, sir.
whatever the correction we should apply here, minus 16, or
Plus
whatever the magnitude that
16.
plus 16, plus 16 into 2 by 3, how much? I'll say 2/3 of,
1.66, sir.
I'll say 1/3 of 16, right? What about the foreign? Fixed and support, that's why half of them will carry. Half of 2/3 of 16. That means here I can say 16 by 3. Now what are the values that we'll get? If you add this, how much we'll get? 16 by 3. If you add, how much will get here? 2/3 of 16. If you add here, how much will get? Minus 2/3 of 16. And here, not required. Movements are balanced or not? Here it is plus 2/3 of 16. Here it is minus 2/3 of 16. So movements are balanced. So what about your final movements? What about movement at A towards B? That will be plus 16 by 3. Here I am just writing. What about the movement at B towards A? It is 2/3 of 16. What about the movement at B towards C dash? It is minus 2/3 of 16. That means here it is how much? I am writing this as X. I am writing this as Y. So here it will be minus Y. Can I write it down? So I am just representing here. What about the moment at this point towards B? According to our convention, X, right? Now, what about moment at this point towards A? Y. What about moment at B towards C? How much it will be? Minus Y. Can you tell me what about here? What about moment at D towards C? Are you guys getting what I'm writing there? I'm not writing in it like it every time it will be difficult to represent plus 16 by 3, 2/3 of 16. That's why I'm writing in terms of X and Y. Or do you want me to write in a big picture?
Yes, sir.
This is A, B, C. We will represent it. We'll represent moment at A towards B. How much we have got? We have got it as a 16 by 3. I'm just writing, oh sorry. Even 2x is also not required. Let us say it is 2x. It will be minus 2x. Or remember, imagine it is, or else leave it, plus 16 by 3. And what about here? Moment at B towards A, it will be 2/3 of 16. What about moment at B towards C? Minus 2/3 of 16. Can you tell me what about the moment here? We just need the moments here, here, here also to write. So can you tell me how much moment we will get here? We have solved one part and we have got the values. What about on the other part?
Will be opposite of that, sir.
Yeah, opposite of it. So how much will be here?
A
Magnitude will be
minus 16 by 3 at point D.
here it will be minus 16 by 3 at B towards A, and here it will be minus 2/3 of 16, and here it will be plus 2/3. Now you got the finite moments, then you can solve the problem, isn't it? Solving an entire thing is easy, or solving this half part is easy. No need of much iterations, right? Am I right? Have you understood how we have solved this? Instead of considering this entire frame, we have just considered only half of it. So much of calculations will be reduced. So the heart of the problem is here only. If the symmetry of the section is falling exactly at the middle of the any beam or column, then we have to consider the new stiffness as half of that value. If it is falling entirely on one of the support, then we have to consider the entire stiffness. Is it okay? At least Samir, please respond like where you did not understand so that we can discuss. It's fine. Whatever you ask, it's completely fine. We can discuss it. Only two of you are presenting, so.
Shall I send one question, sir?
Yeah, you can. Are you solving other questions? What about this problem? Is it okay?
This is okay, sir.
So can you think of this problem? How can we solve it quickly? If you want to solve it by using moment distribution method, how much time it will take? And if you want to take the advantage of symmetry, how much time it will take?
Symmetry in the sense only half the thing we can consider.
Yeah. If you are taking advantage of symmetry, can you quickly tell me how many slopes are zero here? If you are taking advantage of, yeah, the slope at point C will be equal to 3, right? Then how this column will behave then? As the slope at point C is equal to 0, it won't be 0. I can consider this as a, I can say axially loaded column. I can say it. As the rotation at point C is equal to 0. And if you want to solve it by using symmetry, then I should consider like this only. Isn't it? In this case, is there any need to do the reduction in the stiffness? Just like in the previous example, is there any need to reduce the stiffness? This I can consider A, B, C. And what about the stiffness that I should consider KBC? Do we have to consider half of KBC, or I can consider the total stiffness as it is given?
We can take total stiffness, no, sir?
Yeah, we can take the total stiffness.
Because both are.
You are mean to ask about 4.5?
Sir, yes, sir.
What's that? What they're asking about?
Box section we have given, sir.
And what they're asking distribution factors, right?
Yes, sir. Yes, sir.
For A, B, and AD. What do you think the answer is then? How much you have got it?
So you are asking the answer, sir?
Yeah, by looking at directly, can you get some conclusion? What the answer is? No, I'm asking you. I'm not asking about the answer. Like by looking at they're asking only the distribution factors, isn't it? Now, can I know where the problem is?
Sir, there is no support, sir. How can we find, sir?
These are continuous members, isn't it? We are discussing about either there are fixed joints or they were continuous. Whenever you are talking about the continuous, the moments will be transferred there. As you can see here, everything is a continuous joint. So moments will be distributed there itself, everywhere. So there is no sort of pin support, nothing like that. Everywhere it is, you have to consider it as a continuous support. That means at every supports, moments will. So by looking at the diagram, I can say that B is the answer, AB. AB is the shortest span, so for AB, we'll have the larger effect AB, AD. So AB is 0.67 and that is 0.33. Eyes are same, right? Moment of inertia is same everywhere.
Yes, sir.
So obviously one length is 5 and another length is 2.5. So AD is 0.33 and AB is 0.67. That's it. Do you have doubts for that problem?
No, sir, got it, sir.
Yeah. So any doubts in mode distribution method?
We'll go through the problems, sir.
Problems
Just I've seen some 10 problems, sir. Once
So-
after go through it, I'll let
That's
you know,
fine.
sir.
That if you go to the problems, obviously that doubts will arise, but whatever we discussed, that's fine, right? We have discussed about the symmetry today. However, in these types of cases, how do we have to approach here? What do you think the corrections will apply here in this case? Where is the difference that we have to consider?
There will be a lateral deflection here, sir.
Yeah, it is a sway case, right? Because of the load, the sway can occur. So whenever the sway can occur, I hope you guys can remember it can be a lengthy process. And directly you can assume that you cannot just directly obtain the moments as we have discussed earlier. So obviously we can think that you just have to identify that on what cases they are lengthier or what cases you cannot directly apply the moment. Still you can solve this problem by using the moment distribution method, but I don't know whether you guys remember or not, the procedure will be a little bit lengthier. So that's why even in the exam, I think as of now, there is no question that has come from sway type of problem because that will be very lengthy. 2 times we have to do the moment distribution method tables. 2 times you have to do the iterations and then you have to obtain the final moment. So in the exam, don't expect that you will get these type of lengthy problems. But as you can see here, even though this problem looks like very lengthy, but if you take the advantage of symmetry, this problem is of nothing. So that's why this problem we can solve it by using the moment distribution method within a less time. So if they ask you or if they have given you the very big problem, then you can think of advantage of symmetry. Why? Because the calculation will be very much reduced. Other than that, I think that's fine. Now let us talk about the matrix methods. As already we have discussed, this you can solve it by using the either stiffness method or either we can find out the flexibility method also. Already we have seen the relation that stiffness is equal to 1 by flexibility or flexibility equal to 1 by stiffness. If you find the one component, then other component will be easily find it out. Let us start with the simple case. Let us say I am considering a simply supported beam. Now, what is the kinematic indeterminacy for this? Let us say if this is support A, support B. What is the kinematic indeterminacy? There is a rotation at A.
2, sir.
There is a rotation at B. Right? Now, if you want to solve it, let us say from using matrix methods of analysis, then you can say whatever stiffness into your displacements, that will be equal to your forces. Isn't it? If you know one component, then you can get the another component. This is not a flexibility, this is force, load vector. So whenever you want to find out the stiffness method or matrix methods, if you want to find out the unknown displacements, then you can use this matrix formation and then you can get the required unknown. Now, in this case, as you're having the 2 unknowns, your matrix size will be 2 by 2. Or you can imagine that a degree of freedom times degree of freedom. So if you are having 2 degrees of freedom, then your stiffness will be 2 by 2. If you are having 3 degrees of freedom, your stiffness matrix will be 3 by 3. It's upon the number of unknowns. If I just write it down simply, Let us say, according to this problem, I will write it down. KAB, KBA, plus KAA times what are the unknown displacements here? Rotation at A and then rotation at B. That will be equal to what about the force corresponding to point A, what about the force corresponding to B. Now, as you can see here, this is what your stiffness matrix, this is what your unknown displacements, and this is what your force matrix. Now, whenever we are representing, whenever you are representing Aij, so always remember the first one you are representing the force, and second one you are representing the displacement. That means what you can already we have discussed. What is the stiffness we am talking about I? Where I am finding the force at I, where I am finding the displacement at J. That means if I apply the unit displacement, if I apply the unit displacement at watch point, if I apply the unit displacement at J, what is the force required? I am saying force required at I, or I am saying force generated at I. Anything is possible. If you are applying unit displacement at J, how much force required at I? Based on this, can you look at this KAA and tell me where you are applying the force and where you are applying the displacement? The first term represents the force, second term represents the displacement. You are finding the force at A, you are finding the force at A by applying unit displacement at A. What about here? You are finding the force at A by applying unit displacement at B. What about here? You are finding the force at B by applying unit displacement at A. What about here? You are finding the force at B by applying unit displacement at B. So if you think of this first column, where you are applying the unit displacement, see the second one, you are applying displacement at A, you are applying unit displacement at A, right? So if you're talking about the first column, so whenever you are talking about the stiffness matrix, if you want to estimate the first column, in this case, where we have to apply the unit displacement, apply the unit displacement at A. After applying unit displacement at A, what you should do? You should find out the forces required at A, and also you have to find out forces required at B. Similarly, how we will generate the second column?
Yeah, to apply displacement at B.
You have to apply the displacement at
B.
Yeah. You have to apply the second column, you have to apply the unit displacement at B, and then again the same thing, force required at A, and then you have to, oh, sorry guys. Sorry, it got disconnected. So, if it is a display, if you are wherever you are finding the stiffness matrix, if you want to get the first column, you have to apply the in the present
Screen
case.
is not visible, sir.
Sorry?
Screen is not visible, sir.
Yeah, it's got restarting. It
Okay,
got
sir.
started.
Okay, sir.
If it's taking time, we'll continue tomorrow, but I'm just explaining that. Imagine joint A is 1, joint B is 2. Theta A is 1 and theta B is 2. So if you want to apply the first column of stiffness matrix, where you have to apply the unit displacement, you have to apply the degree of freedom corresponding to 1. Here assuming theta A is 1 so that it will be simplified. So if you want to find out the second column of stiffness matrix, where you have to find the unit displacement, you have to find the unit displacement at 2. Just like that, if you are having n degree of freedom, so corresponding to each degrees of freedom, each column of the stiffness matrix will be found out by applying the unit displacement at the corresponding column, and then we have to generate the forces required or generated at each and every point. At least the basic is clear how what is the stiffness matrix and how we are going to apply. Once you know, or once you have generated the stiffness matrix, forces will be given on the problem. So forces will be generated in the corresponding substituted matrix, and then you are going to be able to find the displacements directly. Is it okay? Basic of just like the same thing. You can use the flexibility matrix also. If you're using stiffness matrix, what you're talking about? You're talking about stiffness times displacements is equal to forces. But if you're using flexibility matrix, then what you should do? Ulta hoga, it will be reverse of it. Flexibility matrix times forces is equal to displacements. Shall you continue tomorrow?
Yes, sir. No problem, sir.
What do you think? You guys do the moment distribution method problems and send it to me by tomorrow. I think you have time till Wednesday, right?
Yes, sir.
So wherever you are facing problems, send it to me. We'll discuss. Don't forward me at present. What is the
Tomorrow you have class, yeah?
Tomorrow, no. Tomorrow you are having another classes, right? Which class is going on parallelly?
Parallel building materials. Sir.
Okay, I think actually I asked for continuous classes this week, but as other classes going on, I could not get it. So we'll take Wednesday and we'll take Friday.
Okay, sir.
Please solve it. I don't know why, whether you guys are doing it or not.
Okay.
As
No,
only
sir. Yesterday recording till now we can't see that.
I don't have recordings actually. I'm not managing that now. So it will be just remote sir only.
So it's already uploaded, sir. I didn't see.
Okay, what about Rami? Are you solving? I don't know why you guys are so quiet. Only two of you are presenting. What about others? They are get rid of this analysis part.
Sir?
What about other people? Are they are not interested at all for essay or what?
Nothing, sir. No, the others were not covered. Other classes also not attended, sir.
Okay, others
They are
also.
interested in recording, sir.
You can do one thing. There are a lot of problems that will be from moment distribution method. As you guys have around 2 days of time, solve it and send it to me before 7 o'clock on Wednesday, so that I can discuss you one on one. It doesn't matter where you are handed, just send it to me. We'll discuss. Is it okay?
Yes, sir.
Okay, sir.
Continue it.
Thank you, sir.
Thank you. Thanks.
Thank you, sir.